Now hello again everybody, and welcome to part 3 of the Iwatsu 5702 repair. Now if you remember last time you joined me, we were looking at the time division, the time-based control that wasn't working properly because of that faulty contact. Well, we've done our repair and yeah, it seems to be okay now. It's not stopping, because what it was doing before is you would just set it to maybe one of these high speed 0.1, I don't know, 0.1 microseconds, and then you would touch the control and the dot would just start crawling along, or in fact just stop like that. Well, it is actually working now, so yeah, I'm happy with that. We've made some progress there. But one thing that we haven't made any progress with is the trigger problem, or rather, when we touched up the solder joints and you know, cleaned the board and did, you know, reassemble the connectors, the trigger problem still remains, which I guess is not unsurprising. So yeah, I mean, sometimes you can almost get it to trigger. You know, it's trying, but yeah, just not quite there. I think the trigger circuit though, internally, and basically the way the trigger works with the sweep control is actually okay. Because if I actually choose external trigger, I'm just going to take a piece of wire here and short out the input to the trigger control. It's going to call me a lie. Is it going to trigger? There we go. It triggers now. Although the trigger is right off to one side. And I think maybe that's because I was tweaking some of the potentiometers to do with the trigger adjustment when I was looking at the problem the other day. So yeah, it probably needs some readjustment. But it certainly won't trigger off channel 1, and it won't trigger off channel 2. But the fact that I can get it to trigger from an external input means that basically the trigger circuit, where it actually starts and stops the sweep, that's obviously doing what it should. So it's something to do with the way that the main vertical signal, if you like, is being pulled off the trace 1 and trace 2, and maybe the trigger preamplifier, something like that. Just put it back onto trigger source channel 1 there. Again, you can kind of do the old trick of just playing about with the sweep speed, just taking it from the cal position, and you can actually get, if you hold your tongue at the right angle and all that lot, you can actually get the sweep of the oscilloscope just to be in line with the input signal, and you can almost get it to stand still. It's kind of a lot like you know, a strobe lamp, where you can actually freeze the motion of something. If you just get the trigger speed set right, you can actually get it to work. And in fact, I seem to remember I've actually had some very old valve oscilloscopes in the past that don't actually have a trigger control. All they actually do is have a kind of a variable time base, and you just have to tweak the time base control and hold your tongue at the right angle, and that's how you actually get the frozen image. But we need to fix this trigger control, so I think we need to investigate a little bit further. So what we've got here, we've got this IC301, which is a video amplifier, and this is meant to produce an output which goes to the trigger circuit of the oscilloscope. But when I was testing this IC, I couldn't get anything on the output, which is pin 8. I also couldn't get anything on pin 1 or 4, sorry, 1 and 14. Pins 1 and 14 are the inputs, and basically this chip is used as a differential amplifier. So basically, if you was to look at the signals on pin 14 and pin 1, you'd actually see the kind of complementary, they're opposite to each other. But strangely enough, the signal doesn't seem to be getting this far. But if you look at what's feeding this preamplifier, these you can see there's a set of diodes there, and a set of diodes there. And what these diodes are doing, they're being used as a diode switch. So that is the trigger information for channel 1, and this is the trigger information for channel 2. Now the way that the amplifier decides which trigger source you want to use is there's two control lines here, which I've written orange and red against them. So what these control lines do, they actually put a bias on either of these two diode circuits. So if this circuit is biased, basically the signal comes through to the differential amplifier. If this one is biased, this one is turned off and the signal comes from here. So I guess what I should have said, so these two controls here actually connect to your trigger source control, which is actually on a separate board. So I've been having a poke about here, and as I say, it's not quite right. I can't quite figure out what's going on. Also, I'm not exactly sure how these bias controls actually work, because normally when I've seen these in transceivers and stuff like that, I mean these diode switches are quite common. I see them a lot in various transistorized transceivers and things that I'm used to working on. But usually when I see them, you might put I don't know, 5 volts on these bias lines, whereas all these control lines actually connect to is effectively another set of diodes. So I'm not exactly sure how the actual how these diodes are being biased here. I haven't really figured it out yet. But I'm waffling, aren't I? But the strange thing is, I seem to have a good signal on this side of the diode switch, but I don't seem to be getting a signal on that side, which would lead me to think there's something wrong with the biasing. But it's such a simple circuit. I find that hard to believe, and also the switching circuit does appear to be working depending on whether or not I flick the switch to source 1 or source 2. I am getting some bias appearing on the two control lines. So yeah, it's a little bit confusing. Now the other thing is, I've actually noticed that this video amplifier, which I think it's that one, that particular chip looks not very healthy. The markings on this chip are very hard to read, and when you actually look at this chip, the legs on it look as though they're kind of rusty and burnt. It just seems strange that all the other chips look okay, but this one just looks suspect. So even though I can't actually find anything wrong with it, I've tried voltmeter measurements on it. I think the problem is this chip isn't even getting a signal. But I think what I'm going to do is I'm going to change this chip out anyway, because it just looks bad. I'll see if I can bring you in and maybe you'll see what I mean. So this is the IC that I was talking about, which is basically, it's a differential video amplifier. And I don't know if you will be able to make out, but the legs on this chip, they just look discoloured, they look rusty. Almost like the chips had water damage. Now, I know that doesn't necessarily mean it's electrically damaged, but it just seems strange that the signal seems to stop around here, and all the other chips are the legs aren't discoloured, they just look like normal ICs. But there's just something funny looking about this chip. Also, I couldn't read the markings on it, so again, I don't know if it's been hot in some point in the past and it's burnt out. But I don't know, but just for my own peace of mind, I'm going to suck this chip out, I'm going to take it out and I'm going to replace it with a new one. Okay, I think just before I do that, I think I should just show you though what I mean about the chips not getting the signal. So this IC 301, this video amplifier, the output pin on this is pin 8. Actually no, I won't start at pin 8. I'm going to start off with the input side to the diode switch here for channel 1 and channel 2. Well, we'll have a look at the input side to channel 1 at the moment. So what we'll have a look at is we'll have a look at the what would you call it? We're going to have a look at the input to the diode switch, not the output. So if I look at the input to the diode switch, that's going to be developed across this D302. So there's our signal, D302. That's what I would expect. But this signal developed across D302, it should also now be on pin 14. So basically, if I just go to pin 14 of this IC, we should be seeing the same thing on the scope. So again, I'm just going to go back to the input to the switch, and now I'm going to have a look at the output from the diode switch, and we're getting absolutely nothing. And it doesn't matter which am I on the right thing there? No, it doesn't matter which channel I select. I'm still not getting anything to the actual IC itself, and yeah, I've got to admit, I just don't understand that. If we actually have a look at the bias levels, we do seem to be well, all I'm going to say is we are getting changes in bias levels. Whether we're getting them correct is a different matter. So let's just have a look at the bias level to the diode switch. Okay, so this is the bias level now to the diode switch. If I just select the other opposite channel, you see, so it goes between -5 and 0 volts, and from what I can tell, that's what I would expect to happen. So the diode switch is getting a bias. I've actually checked all these diodes and they seem to be fine. Well, basically they passed the diode test on the fluke meter. Now the other thing is, because there's two lots of diode switches, although you might get a fault on one circuit, it seems more unlikely that you'll get exactly the same fault on both. So yeah, it just doesn't ring quite true. But this IC301, this is what a component which is common to both. I thought it was possible that the inputs to this IC301 were perhaps shorted out, because that would result in the signal being effectively just shorted out. But no, that doesn't appear to be the case. Again, when you take a DC measurement, a resistance reading across the input of the video amplifier, you see about 800 ohms, which is effectively what it should be, because there is a couple of 430 ohm resistors strapped across it. So all I can say is it's all very strange, but there's definitely nothing coming out of the video amplifier. But the strange thing is there's nothing going into it either. So yeah, it's fair to say I'm very confused, but I think for my own peace of mind I need to swap out this this diff amp chip. And of course, to get this board out, we're going to get some more knobs off. Let's hope these come off a bit more easily than the others. Tell you what, for your sanity, I'll take these knobs off and I'll bring you back. Well, I've got all the knobs off now, but I just thought I'd comment. When I was actually trying to get these grub screws out, they did look very rusty inside, and a lot of the screws on the outside of this scope are quite rusty. And there is also some rust on the inside of the scope. So I'm guessing that, you know, this oscilloscope has been stored in a damp or a wet place. Again, I'm not saying it's necessarily related to the trigger fault, but it just seems strange that the legs on that chip all appear to be rusty as well. So I'm just wondering if some water has got into this in the past. I don't know, but it's a thought, isn't it? that going to be out? Okay, we've got the board pulled out now, and hope you can see a bit more clearly this chip, this IC301, which is this video amplifier, differential amplifier. The pins on this particular chip, they just look corroded. I don't know if that just means that, I don't know, maybe when they were manufactured the plating on them wasn't very good. But for some reason, they look different than all the other pins on all the other chips. And that's just enough for me to make me think there's something suspect, especially because the signal is stopping around this part of the circuit. So I'm gonna take this out in a minute, and we'll see if that improves anything. So we're gonna have a go at desoldering this IC301, and to do that I'm going to use my paste desoldering station, which generally works quite well. It really sucks. If it could cook tea, I'd probably marry it. Yeah. Just thought I'd throw in there a misogynist comment. Hopefully it'll upset somebody. Oh, maybe you can see a bit more if I hold it that way. I'm taking the right one out, aren't I? Yeah, it wouldn't be the first time. The tip in here is actually a little bit big. It's not a very good fit. I think we'll manage it. There we go. Little sucker's out. Can't really see anything particularly wrong with it. Again, a little bit of corrosion around some of the resistors and stuff there. Probably give this a clean up while we've got the chip out. I think we'll put the new chip in, and what I quite often like to do is, if I've got a socket that'll fit it, I'll put the new chip in a socket, because if it's gone once, maybe it'll go again. Well, we don't know if it has gone yet, but when I reinstall chips, I like to put them in sockets. It makes the job easier next time if you ever have to come back. I've always got hundreds of sockets, but never the one I actually want. Is that the one? Nope. Too many legs. Yep, you'll do. Right, okay. Although it's not necessary at all, I have become a little bit addicted to using flux on things. It just seems to make the job quicker and easier. I guess one of the other advantages I've found with using flux on old boards is that if you've got an old board, it can have, you know, oxidization and stuff building up. And the last thing you want to do is be, you know, scrubbing it away with a joint with a soldering iron to try and get the solder to run. Because, you know, you stand a good chance on an old board of just heating it up and one of the pads coming off. So if you just put a little bit of flux on it, you just guarantee that you're going to get a quick joint. So just tack the corners. He said burning his finger. Ow. And I have got it in the right way around, haven't I? God. The amount of IC sockets that I've soldered in backwards, it's embarrassing. It's a good job that the flux residue giving off solder is really good for your health, especially if you suffer from asthma as badly as I do. I don't know what I'd do if it wasn't for all the solder fumes that I inhale. Well, it looks good to me. Can you see? Which one is it? That one there. Do I pass? IP certified? I think not. Yeah, I should be certified, that bit's true. I'm just going to check all these diodes that are used in the diode switch arrangement. So it looks like this this bank of diodes here is used for diode switching for channel 1, and this bank of diodes down here is used for diode switching for the channel 2. Maybe if you put your test leads the right way around. Okay, that works. I'll have to edit that out. Right, forward voltage 0.5, 0.5, well alright, start again, 0.58, 0.59, 6, 0.6, 0.6, 0.6, oh, don't need to check them, let's check these down here, 0.59, 0.58, 0.59, 0.6. Let's just check it in the reverse direction. Nothing, 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 nothing. That looks alright then, doesn't it? I'm going to give them a clean because again, just so I have. Right, for those playing at home, the chip that I keep referring to as a video amplifier, it's a UA733CN. You know, the other thing I wish I had some of those IC insertion tools. Years ago when I used to work at Tandy, well I say I used to work at Tandy, I used to work there for about a month before I got fired. It was my first school job, part-time job while I was at school. Still don't know why they fired me. I quite enjoyed that job. I think it's because I told the customers the truth and it probably didn't go down well. Yeah, they used to sell, you know, like little syringe things, and they would insert ICs, and I always find that ICs are a little bit difficult to insert. I mean, the idea is that this package, that it should present the legs to be squeezed in just enough so they go into the socket. But they just don't. I mean, it's just nowhere near it. Yeah, I mean, yeah, rubbish. I'll pick the bugger up and push it in. These are the turn pin sockets that I'm using. I only ever use turn pin sockets. They tend to be slightly more expensive, but they avoid a lot of problems. But they are actually not very forgiving for getting the legs of an IC in. If you just basically force it in, you end up bending them like bananas, and I've lost count the amount of times I've done that. In fact, this one is trying to do just the same. Right, okay, got you in. Have I got that the right way round? Can anybody tell me, is that right? Yeah, I think it's right. I'm just getting you to check because I always put them in the wrong way around. Right, okay, let's put this board back in. Not expecting necessarily it to work. In fact, in some ways I would be surprised if it did work, but at least I'm not going to worry about it being faulty anymore, this chip. Okay, well, we've got it all back together now. Now, I'm not a betting man, but even if I was, I don't think I would have a pound bet on whether or not it'll work. So I guess we better find out, haven't we? Will it trigger? Come on, baby. Will it trigger? Will we even get a waveform? Will we get anything? Can't see anything. Oh, wait. There she blows. There she blows. Okay, so it was that video amplifier chip that was duff. Let's check. Does channel 2 work? Yep, channel 2. Lovely. Will it display both of them? Yeah, it will. Looks like we might need a little bit of adjustment there. Does it trigger on channel 2? It does. There she blows. Well, on that bombshell, that'll do. Thanks everybody. Bye bye.